So, it's a pleasure to me to introduce you Fady Salama and Roman Binkert. Fady is a research associate in the professorship of the embedded system and IoT at TUM. He began his research journey by exploring innovative approaches to integrating the Web of Things with complex cyber and physical systems. And Roman is a research associate at the same research group as Fady. He's interested in the Web of Things and how to apply it to manufacturing. So, without further ado, Fady and Roman, the floor is yours.
So our topic today is how we used the Web of Things to build up immersive mixed reality applications. So next slides. Yeah. So our motivation is, basically normally when you have IoT, for example, in a smart home, you use your mobile phone to access your devices, to see what is their status, how you can interact with them, and so on. And that is nice. But if you look, for example, into in the industry, for example, this is not as easy. If you have a robot arm, for example, in front of you, usually these robot arms don't have a nice interface beside them, and you can, of course, use your laptop, your tablet to maybe view the information about the device, but it is not as easy and not as immersive as augmenting your eyes to be able to communicate and interact with the device. And you can even go further, and if you like in a factory, it's easy to have like devices, but maybe you are on the field in agricultural scenario where it's basically you have sensors that are distributed and you don't have any way of communicating with them or interacting with them or even initiating them, because there's nothing other than your devices that you have with you. And of course you can do that with a phone or a mobile or a tablet, but augmenting how you see the devices is our goal. So to sum it up, our problem statement is basically across all these different domains, in agricultural, smart home, or smart factories, you don't have this one immersive XR application that allows you to interact with any kind of device that you have in front of you. And this lack is basically because, of course, there is such a huge fragmentation in the IoT environment that you would basically need for every group of devices, you would need your own implementation and how to connect your immersive application to that device. So to discuss then our approach, we wanted to implement a mixed reality application called HoloWoT, which is immersive, seamless. So there's as little clicks needed as possible to be able to interact with your device. It is our aim was to have it cross-platform compatible. So on top of, for example, OpenXR, to allow the use basically with any kind of mixed reality headset. And the idea is that you have your mixed reality headset, which scans, for example, a QR code. That QR code points to the thing description describing the device that you want to interact with, and that device and that thing description is then able to be used to dynamically generate some kind of UI that you can see in front of you inside the device, that you can use to interact with the device, read its status, or invoke some actions that it can do. And you wanted to make sure that there's no need for an intermediary or anything like that. So there's no clouds needed. Of course, you can still access devices even if they are in the cloud. because the Web of Things allows for that. But you like in our application is all inside of the headset basically, and of course the connectivity is established using the Web of Things. So the project has two parts: the communication and the interaction. And to introduce the communication, we will need to introduce the Web of Things to also those people here that are exposed to the Web of Things for the first time. And this is where I give the helm to Roman.
Yes, exactly. Since we hear that some people might not know about the Web of Things, some people from the XR group from W3C, I will briefly introduce the Web of Things and then also some background to the HoloLens and how to program for that. So basically what the Web of Things is about is to enhance the IoT interoperability by applying standardized web technologies. For example, like Ege mentioned already, we have a controlling device and we want to control a robot arm, but we don't only want to control a robot arm, but maybe also a drone or some wind farming, like agricultural stuff. And they all might use different protocols to interact with them. And to make the interaction with all these unique, this is basically the goal of the Web of Things. One of the most central parts of the Web of Things is the so-called Web of Things thing description. And it basically is what you can see on the right side. This is actually one thing description we have for a little robot arm. And it uses interaction affordances to describe different ways of interacting with a device. You can have properties, which are some statuses or something that you can read, and actions that you can invoke to do something, make the device do something, and finally some events that kind of can be pushed by the device to you once you subscribe, so you can get notified when something changes there. Of course, you can also, since it's a JSON document, you can also enable and enrich it with general metadata, like of course a title, some description or ID, or also some security information. And also what we see here on the right side is like this type thing here is called so-called data schemas. So they really describe, okay, what an action that we call in this case go, what kind of input it takes. So in this case, it takes a speed, a JSON object with speed, X, Y, and Z values as inputs, and then we need to send these values in this format to the device so that it can understand us. And then the second part that is important there is the so-called forms. So like I mentioned, that Web of Things tries to be or is protocol agnostic, and based on these forms, we match one interaction affordance to an actual protocol specific requests. So down here we can see how this request would be matched to HTTP or to MQTT, for example. And finally, Web of Things has also more. So we saw the thing description, which is here on the left side, but it also offers binding templates, which are like these templates for how to bind these forms we just saw in the recent picture to different concrete templates. And then also it has, like, for example, the scripting API, which Cristiano mentioned before, this node WoT, which helps you implement devices and things with Web of Things. And now to the more background for our topic today. So we use the Microsoft HoloLens 2, which is an AR headset. So it's similar to different VR headsets you might know, like, for example, the Apple Vision Pro or also the Meta Quest. But the biggest difference here is that it's an AR, so augmented reality headset. So as you can see on the bottom left, it has actually some see-through goggles. So you can see, like here on the right side, not an image or a video live stream recorded by cameras of the real world, but you can actually see the real world through it and get like a holographic overlay of the information you want to put there. And you can interact with the HoloLens via gestures, voice, or eye tracking as it cameras. I think you can maybe see them here. here and also here, that also capture the environment, also from this your hands, and therefore you can interact with hand gestures and also talk, of course, and it also tracks your eyes, so we can know where you look and what you want to focus on maybe. Lastly, it also maps the environment, so you know exactly where in space you are. It knows where in space you are and where in the room you are, and therefore you as a programmer can put anchors somewhere in the room and something stays in the room at the same position. So to program for the HoloLens, we use Unity. You can also use Unreal Engine, but Unity is quite popular here. It's a cross-platform game engine. It came from gaming, developing games, but now it's also widely used for XR development. And basically, as you can see on the right, it has some game objects and scenes. So this is like the visual part, how this is structured. So you have these different objects, like assets, like a ball or whatever. And then you can have C# scripts to control or act on these assets. And the mixed reality toolkit from Microsoft is what is used to capture all this spatial awareness and gesture recognition, what I talked about before, and give it to the programmer so then that we can interact and program on this. And also the OpenXR plugin, which is also from the mixed reality toolkit. It's a plugin that allows you not to only develop for the HoloLens, but also be able to execute this on other devices that support OpenXR. And with that, I will hand over back to Fady for more details.
Coming back to the project, so now that we know what environment we were dealing with, we needed, so we wanted to communicate using the HoloLens with Web of Things enabled IoT devices. But of course, if to do this, and if you're programming in Unity, you need the scripting API implemented in C#. And sadly, there was no other implementation before, so we had to do it ourselves. So we started WoT.net, which is implementation of the scripting API, which allows it to deserialize and parse thing descriptions, handle till now just only HTTP or HTTPS requests, but more in the future, hopefully. We can handle security, mostly basic security, also digest and talk and API keys. Anything that you can put in the header is usually easy to use. .NET, it's built upon the .NET Standard 2.0, which makes it widely available for many devices. It's totally open source. You can find it here. There's also a QR code if you want to have a look. And the project is built in such a way that you have basically a core library, and that core library is just a definition of all the all the things that are described in the Web of Things. What is the thing description, the different schemas, the different interfaces that you would expect. And then similar to how the Web of Things is structured, we also have this core standard, and then there's different protocol bindings. So now the WoT.NET binding.http, this is already implemented, but in the future you can have WoT.NET binding CoApp or MQTT or XYZ, whatever you want. So you just need to implement the interfaces that are described in WoT.NET Core, and that is very similar to already what is defined in Node.WoT. So we're not reinventing the wheel, but rather just making sure that we have a C# port of the scripting API. And as I said, in WoT.NET Core, you can already see like it describes the definitions. If you want to have a look at the documentation, it is there in the through this QR code, or maybe Egi will put the link in the chat. And the idea is basically that mapping between what is defined in the scripting API and C#. And for example, if like there are these JSON schema types that we use when we are talking in the context of the Web of Things. But of course, some of them are not defined as such in C#. So we need to do that mapping ourselves. And it's very briefly described here, for example, that a null in JSON schema is null in C#, Boolean is a bool, integer is an integer, a number is a double, a string is seen as a string, an array is a list of a certain type. So we cannot have arrays of multiple types as in JSON schema, for example. Or an object is basically a dictionary with a string and a certain type attached to it. And of course, there are other interfaces. If you go to the actual links, you will find the full description of all the interfaces that we described. In WoT.NET.binding, we are basically implementing the interfaces. It's similar to the interfaces defined in Node.WoT. For example, what is an HTTP client and the client factory, which is basically building the clients. These are the ones that needs to be implemented, as well as all or security schemas that are defined for that binding, for that protocol. So again, you can have a look at the actual documentation through that link. So that was the first part, which is the communication. And the second part is, of course, the actual UI and the actual interaction. So the XR application that we built using in Unity and C#. And we built it on top of the MRTK toolkit, Microsoft's Mixed Reality Toolkit, which pleasantly also is built in its third iteration on top of OpenXR, making it possible to use that application that we built in any mixed reality headset. Of course, it's an augmented reality application, so it is not going to work well in VR headsets because in a way, you also need the QR code scanning and all of that to be able to actually see any kind of device or UI for the device. We use canvas-based UI elements, so it's basically menus that are defined by in Unity, but of course are adopted in OpenXR in MRTK. QR code detection and tracking is built in using the HoloLens's cameras, and for each kind of interaction, we build specific prefabs, which you can see in the next slide. So you can see here, for example, for properties, you can read them. So you have a UI which just allows you to read. If you can write them, you can write them. If it's a Boolean, we for example, use a switch if it is a number with a minimum and a maximum defined in the data schema. We have a slider. If it's a string, we offer a text field, although writing in mixed reality is not the best thing. You can observe and unobserved properties. You can invoke actions, or and if that action has a certain input, again, we put in the specific UI element that corresponds to the kind of input that you have. Enums are lists. numbers that have a minimum and maximums are on the slider. If it's something generic, we can use a text field. And similar to, again, subscribing to events and so on. By the way, that UI that you see here is the first iteration, because we have another iteration afterwards, which we'll talk about in a second. But basically, the application flow is as follows. You first have your device in front of you, which has a QR code pointing to the thing description of that device. You scan it using the HoloLens. You can see then the URL that is pointing to the resource, to the TD, and then fetch the TD, which then allows you to see that inspector view, which shows you the thing description on the left, all the properties and actions and events on the right, and you can then click on the certain interaction you want to have, and then you will see its name, its description, what kind of operations you can do on top. If you want to scan the QR code again, you can scan it. That UI can also move, so you can pin it to a certain place in the space, but you can also unpin it and move it around as you want. So that was the first iteration, and I hope in the next video it will not be very choppy and you can see at least something. So yeah, this is how it looks. And you can then click on the reading the properties, or invoking a certain action. By the way, the device is just underneath. It's not in, you will see it in a moment. This one, and then if you invoke the action, you see the LEDs are not very clear, but they are actually showing a certain message. So that was the first iteration, where you basically have just an immersive menu where you can interact with your device. But of course, this was not enough. So our next question was, how could we design an accessible, scalable, low-code IoT orchestration framework using the Web of Things inside the HoloLens? So basically, we want to build a certain mashup, certain orchestrated stepwise action that you can basically use to perform a certain functionality. So to do this, we needed to also improve the actual UI. We had some feedback for the first iteration, which we tried to solve. The first was the scrolling was not that nice, so we scrolled better. Then we had a separation of concerns, in the way that basically whenever you want to, the inspector is only there just to inspect, so only to show. And if you want to do some kind of writing or some kind of input, you get a smaller menu, which is basically just concerned with putting the inputs. And that menu is in front of you, so you don't need to run to always do a certain interaction. Reading is then on the right side, and then whatever happens is if something is successful or if there's an error, at first we showed it in the same inspector. Now we have like a small window underneath. Other improvements were to the scrollable panel, to make sure that you can scroll nicely. It's not just scrolling with the finger, which sometimes was not working correctly, but you can also have like arrows up and down. Like you can see here. Then we also, if you had an object, for example, it was very hard to show the whole object if it's a big object. But so you can see here, the object before was just like similar to a list, and you had each key would be inside that list. Now what we got is a like a nested structure. We can basically go like as if it was a tree, and you would go in each element tree-wise. And then the last thing here is how to select the input. It was not very nice. Sometimes it was not responsive, and we improved that by what we showed before, the smaller panel where selecting an input is much easier. You have the arrows to make sure that you selected the correct input, and it's sticky and it's not going to it will need less clicks basically. But the big thing that we did is the mashup creation. And the mashup creation is where you can basically imagine you are in a factory and you want to do some testing, or you have an idea and you want to just test that idea and interact with the devices in that way. So the idea was here that in that factory you would see all the devices having their QR codes. You go to them, you then see dashboards describing each device, and then you can combine these devices and their interactions to perform a certain functionality. So we had a small Fischer-Technik simulation factory in the university, and it consists of a sorting line, an oven, and a gripper robot, which can grip certain products from a warehouse, then can put them in certain positions, and so on. So you would start from the gripper robot here, which can check, like can fetch the product from the warehouse, put them in the oven, and you can start baking that product. For example, if it's wood or if it's metal or whatever, you would put them in the oven. It will bake for a certain amount of time that you input, for example, 5 seconds. And then based on the type of product, you would put them in a certain sorting line. And if the product is red, you put them back into the warehouse. So that was like that there is some kind of condition on top of your actions. And we can see it also here in the next video. So now you can see, hopefully it's not choppy. It will be quite fast, but the idea is here you can see there are certain dashboards, and the dashboards allow you to see the device and interact with it. And then based on the interaction that are available, you can choose that you want this action to happen, and once it's finished, you can want that next action to happen, and that next action can be or interaction can be on the like one of from the same device or from a other device. And if Roman, if you can go back a little bit. So you can pause it.
I cannot pause it for some reason.
Okay, then it will repeat itself. But basically, you already see it. You can see the actual dashboards, and on top of them, the numbering of the interactions that are going to happen. And and then step by step, once an interaction is finished, you can see around it that it's becoming green. So it has these small green markers showing interaction has been done successfully or has been performed successfully. Yeah, and you would then have a full loop, and it was performed quite nicely. And that's the first step in our immersive application using the Web of Things. I think a nice teaser would be the next video that we can show a woman. She's basically going one step ahead and looking at complex devices that have a much higher, probably like much higher actuation capabilities, like a robot arm, for example, and overlaying it. You can see here, you can interact with the robot. And the nice thing about that application that we are I'm teasing here is that because of the Web of Things, you can basically do the same, use the same application for any robot if it's basically defining like a certain interface which is described as the Web of Things. So this comes later. Yeah, I think we are already done. Thank you for your attention. The homepage of the university is here. You can also have both of our emails and for contact. And yeah, thank you for listening and open to any questions.